Hello everyone, welcome to the channel. Today we will be solving Leetcode problem 735 Asteroid Collision. So let's have a look on the problem statement. So here we are given an array of asteroids of integer which each indices of the asteroid is representing the relative position, and the absolute value of the array of the asteroid value represents the size of the asteroid, and the sign represents the direction of in which the asteroid is traveling. Positive means right and negative means left. So after the collision, what will be the state of asteroid, that we have to find out. If there are two asteroids, then if both of them meet, then smaller one will explode, and if both of them are of same size, then both will explode. And it is given that two asteroids moving in the same direction will never meet. So let's look at a test case. Let's say we have 2 3 minus 1 4 6 7, something like that. So this asteroid is moving in right direction, again right. Here another with negative sign, we can say that this is moving in left direction. So there is a chance that both will collide. Okay, so if both are colliding, then we will compare the size. So this one is the smaller one, so this will get eliminated. Like, yeah, this will get eliminated. Now if we look at, okay, now this is in right direction 4, then again 6 in the rightward direction, then we have minus 7 which is in leftward direction. So what will happen, again these will collide, and the one with minus 6, yeah, so we will compare the size, and 6 is smaller one, so it will get eliminated. Okay, then what will happen, we will compare this 4 and 7 size, okay, because both are in different directions, opposite directions. So here 4 is the smaller one, so it will also get eliminated. Then we will compare 7 and 3, here 3 will get eliminated. Then we will compare 4 and 2 and 7, 2 and 7, then again 2 will get eliminated, and at last only 7 will be left. Okay, so like that. Let's say we take some other example as 7, then 2 1 minus 3 17 minus 16. Okay, yeah, so what will happen, this is in forward direction, forward on left direction. So obviously one will get eliminated because of small size. Okay, then we will compare 3 and 2, 2 will get eliminated. We will compare 7 and this, then 3 will get eliminated. Now we'll move forward. 17, both are in same direction, 7 and 17, so nothing to do, move forward. Then this is in another direction, we will compare both. Okay, so 16 will get eliminated, and 7 and 17 both are in same direction, so the output will be 7 and 17, like that. So with this, what's the approach coming in my mind is, we have to do something as if let's say I keep a track of positive elements. Okay, and whenever if I met any negative element, I'll just compare. Okay, let's say for this example, for 7 2 and 1 3 17 and minus 16. Okay, I think it was minus 3, yeah. So for this example, what I was doing, okay, positive, move forward, positive, move forward, positive, move forward. When I encounter a negative in number, then what I will do, I will compare it. What I will compare? I will compare it with the previous element. And let's say if this get eliminated, then I will compare it with the a previous element. If this also get eliminated, then again a previous element. So what I want to keep track of my previous element. So that is something as whatever has entered last to be taken out first. So whatever last entered, last in and first out. So with this, I got the intuition of stack, that I can use a stack. Okay, so what can I do? Again, let's take the same example. Okay, yeah, 7, 2, 1, minus 3, 17 and minus 16. And let's say if I have a stack, what I will do, yeah, I will take 7. Okay, it's a positive number, I'll keep adding. It's 2, I'll keep adding. It's positive 1, no problem, I'll keep it. The moment I encountered a negative value, what I will do, I'll compare it with the back of the stack. We will compare the absolute value of this negative and this last element of stack. Whoever is the highest will keep that, and another will get eliminated. So here 3 will get eliminated. Okay, sorry, 1 will get eliminated. Then yeah, so again pointer at minus 3 only. We will compare another element which is on the top of the stack. Okay, which one is the smaller? 2 is the smaller, it will get eliminated. Then we'd compare it with this one. Okay, which one is the smaller? This one is the smaller. Minus 3 is the smaller one, like absolute value. So we will not eliminate it, we will not pop it out. By elimination, I will pop this out. Okay, but I won't pop out minus 3. It's not present in the stack. I'll not keep it in the stack. What I will do, okay, I just received a value of 7. So what I will do, I will take this pointer at another value. Okay, 17. Now I will compare. Okay, it's positive, no worries, we will push back 17. Then we have minus 16. Okay, then we'll compare minus 16 with the last element. Okay, so minus 16 will get, okay, the stack, the array is completed, so nothing to do with it. Then what we will do, we'll just change our this answer, the value present in this, that is whatever the value is left in the stack is our answer. So that's it. Yeah, you can try out, like, yeah, when the array is completely empty. Yeah, so let's say initially you have something as minus 2, 1. So yeah, you can add this also. When the when n negative value will get inserted only in a case when the stack is empty. Okay, like for example, whenever there is a negative element, for sure there's going to be a collision. There can be two cases. Let's say you have something as minus 1 here and minus 1. Yeah, so let's say you have something here as this. Okay, so minus 1 at the top of the stack. Okay, and you also have here minus sorry, let's say here plus 1 and this is minus 1. Both are of same sizes, so both will get eliminated and nothing to do with another one. We will just move forward. So this is also a case, and this is also a case where if let's say you have a negative element. Okay, so it won't happen that when the stack is filled we have to push this negative element. Okay, what I am trying to say, let's say you have 2 and minus 1. So in any of the case, if we have such kind of test case, it's not possible that there won't be any collision or the final state will be as 2 and minus 1. Okay, I mean, if I enter it in the stack, I'll compare it with minus 1. So what will happen? Okay, collision will happen and minus 1 will get eliminated and final state will be 2. Okay, so there won't be a case where positive negative both number will be there. Instead, there can be a case, let's say I have 2, 3 but minus 16. So I will input 2, then 3. I will compare, okay, minus 16. This got eliminated. This got eliminated. I'm just left with minus 16. So I'll see, okay, stack is empty and no elements are there. So I can push this. So whenever the stack is empty, then only I can push the negative element. Even if, let's say, it was minus 2, 3 and 16. So initially stack is empty, I can push minus 2 in this when the stack is empty. Okay, So yeah, so let's write the pseudo code for this. So initially we will require a function, let's say a vector function. Okay, then we will require a stack, and this vector will contain a vector only. Okay, vector array, whatever you say. Okay, we will have a stack. Then what we will do, we will run a loop from this I equals to 0 to n minus 1, or let's say n, n till n minus 1. Then what will happen, we'll just compare whether the current value, if the current value is positive, what we will do, we will push the value. Okay, if it's negative, then what we will do, we will run a while loop which will check whether this is empty or not. Okay, then the last element, the top element, is positive or not, and whatever the top element is, that is if it is less than the absolute value, if it's less than the absolute value of the current element, then what we will do, we'll just remove it from the stack. Okay, so let's say just a minute. We'll just remove it from the stack. We'll remove, okay, like this. And then we can, I just said that we can have a condition such as -1 we have here also, and we have +1 in our stack also, like that. And if both absolute values are same, so what to do in this case? So what can we do in this case, that if my stack is not empty, yeah, that's obvious, we should have the last value if it's not empty, and if both the values are equal, that is top is equals to the absolute value of the current element, then we'll simply pop this out. Okay, then we will pop this out, that is remove. Okay, again what will happen, we will check if the stack is already empty. If it's empty, or let's say if the top element is negative, what we will do, we'll just push another negative value. Yeah, because in this case we are handling for negative value. And just what we will do, we'll simply just empty our stack into a vector, and we will output this vector. So that's it. Let's have a look on the code. Okay, so we have this stack, then we are running a loop. If it's positive, we'll simply pushing it. If otherwise, if the stack is empty and the top elements is positive, okay, we will compare the absolute value and the top element. Okay, like this. And so we'll pop it, and if both are equal, then again we will pop the only one, it for once time it will get popped out. So only, so no while loop here. And then if the stack is empty and the top, so yes, the top is negative and the stack is empty, we will push whatever the value we have, like the negative value. And for this, okay, we have a I will just empty my stack into the vector. So I have a vector, I'll just did a reverse iteration and I'll just return the output. Yeah, so what will be the time complexity for this loop is running for, we go of n time. Yeah, and this loop At max it will run like, let's say I have all the positive elements and just one last element as a negative element, and let's say it's a bigger value. So what will happen, how many times the pop function is going to be worked out, it's n minus 1 time at max, and only if there are like if there is negative elements like that, it's not every time. So time complexity will be big O of 2n. Okay, and where we are using one stack, so big O of n is the space complexity. For output we are using one vector, but that size depends on the final output. At max stack size can be m, but this space we are using just for the representing the output. Yeah, so this is the code. I hope you like the solution. Thank you for watching.